Hello class, welcome to our lesson today dealing with the beginning of chapter 4, writing and graphing inequalities. We've done a little bit with inequalities already with our previous lesson. We're going to extend some things and make sure we understand some wording as we're looking at these scenarios. First thing we're going to look at is just some simplifying, and mainly this deals with distributing and combining like terms. So in both of these questions you need to distribute, but often the first one goes a lot better for students than the second one. So for this first question, 4 times the 2x and 4 times the minus 8 would become 8x minus 32. Combining like terms, you got 8x minus 3x, which would be 5x. Negative 32 plus 2 would be negative 30, or subtracting 30. Remember, adding a negative would be the same as subtracting. In the second one, you can't combine these pieces together until you multiply, but you're not distributing a 3, you're distributing a negative 3. So negative 3 times 5x would be negative 15x, or subtracting 15x. Negative 3 times a negative 4 ends up being minus a negative or plus a positive, so we can just make it plus 12. And then combine like terms to get the negative 8x plus 12. You just got to make sure that you distribute the negative signs correctly, especially on ones like the second one, in order to get the answers. Okay, the main thing that we're looking at here is, do we include numbers or not include them, things like that. This says you want at least 5 of the photos that you're in. Okay, so the main question is, should the number 5 be chosen? And the answer is yes, because at least 5 is 5 at least 5, and it would be included. And if you want to be in at least 5, it's that number or higher. So graphing-wise, that would be a closed circle and going to the right, but it includes the number 5 and then 6, etc., all the way to infinity to the right side. The next one says you want temperatures less than 4 degrees. The question is, do I include negative 4? And the answer is no. And you want numbers less than that, so there should be smaller numbers like negative 5, negative 6, negative 7 going to the left this time. Some students may try to do a closed circle at negative 5 and say, oh, well, it's got to start at negative 5. But we don't know that because it's got to be between the two as well. So like negative 4.5 would work, negative 4.1. And the question is, well, how far do we go to get to negative 4? And we can get as close as we can without including negative 4, and that's what the open circle does. So it's everything from there going to the left. The next one says more than 3. That should be similar to the last slide, except that it's more than instead of less than. So that would include all numbers that are greater than or more than 3, like 4, 5, and 6. But the number 3 is not included, which would represent an open circle there and everything larger than that. So anytime you're looking at more than or less than, that does not include the given number that you're looking at. The next one says no more than negative 5. That also corresponds to less than or equal to. So the question is, does negative 5 get included here? And the answer is yes, because is negative 5 no more than 5, or negative 5? And the answer is yes, it's the same number. So anytime you're dealing with no more than or less than or equal to, scenarios like that, at least, those scenarios would include the number that you're looking at as the cutoff, which is why it's a closed circle instead of an open circle. Okay, so for this example, it says x greater than negative 1.5. So the question is, can you include negative 1.5? And the answer is no, because it has to be greater than. It can't be equal to. Remember, the greater than or equal to would have the greater than symbol and then the line underneath it to represent equal to. This would represent everything from this open spot at negative 1.5 to the right, because you want greater than. 4 other numbers that would make this work. I try to put some rational numbers like negative 1/2, 0.5, and 3/4, and then I put some irrational numbers that are still greater than. So for example, pi is greater than negative 1.5, and the square root of 35. But those are irrational numbers, but could still be considered numbers that would work for these situations. The next one says x less than or equal to 5 over 2. So can it be that? And the answer is yes, because it has the line to represent equal to underneath. It would be a filled in circle and then going to the left. Again, if you're looking for non-integer numbers, so I got some rational numbers here, as long as they're less than 5 over 2, and then an irrational one. As long as it's a negative square root, it's going to be less than 0 no matter what, so it would work automatically. Okay, so here's the main idea. Greater than or equal to, filled in circle, arrow to the right. Greater than, open circle, going to the right. Less than or equal to, closed circle, going to the left. Just less than, open circle, going to the left. Notice all 4 of these locations have the same barrier limit of negative 2. It's filled in or open circle, and which way do you get the arrow going? That's most important to be successful on these questions. Okay, so this just reiterates open circle less than or greater than, closed circle has the equal to, then which way the arrow goes based on if it's greater than or less than. Another key piece to inequalities is we like to have the variable on the left side. So notice this is x greater than or equal to negative 1.4, which would mean anything higher than negative 1.4 would work. This says negative 1.4 less than or equal to x, but that's really the same thing. If you flip this around, the whole thing's on a swivel. So that less than sign would actually become a greater than sign when you swivel it around. The other thing you can think of is the alligator or Pac-Man. Notice it's eating the x piece here. Okay, so it's still heading towards this one. Pac-Man still, or the alligator still heading towards the x. So they are the same for that reason as well. It's just flipping that piece around, okay, and setting it up to put the variable on the left side. Okay, your homework today is numbers 4 through 9 and 29 through 32 on section 1.4. When you're graphing, make sure you include enough numbers on the left and right side, open, close circle, and which way the arrows need to go. Have a good day, everyone.